Good afternoon.
Hello. Hey, Drew.
Hey, how are you all doing?
Good. Hey, how about you?
Good.
Oh, pretty good. It's Friday. I'm looking forward to seeing folks soon.
Yeah, same.
Yep. Hey, what did we decide on the most important topic? What did we decide about a get together at OCP? I think we decided a day, right?
So the block party is on Wednesday evening, and I thought we'll all gather there. The block party, the front of the building. There's we'll gather on the Marriott side of those stairs, and so when that gets over, we can just walk into Marriott and continue there.
Okay, got it.
Yeah. If someone has an idea for a fun sign to carry there, I'll print it out and bring it.
Sounds good.
So Anil wanted to share something today. He wanted 15 minutes or so. So that would be one thing we need to cover today. Another thing I was thinking of canceling not only the week of Global Summit, that would be 20th, but also the Friday before that, because I'll be traveling Monday, and I'm sure I could take care of some of the things so I don't get in too much trouble for not being at home for a whole week.
So, like, you're talking about next week then?
Yeah, cancel for 2 weeks.
That's fine. I'm going to be going to a college reunion, so I'll be gone. I'll be gone next week as well.
Sounds good. So how do we proceed today? I think there's no point in waiting for Anil. I don't know if he's aware or not. He might be on something else. So how do we proceed today? Do we have any opens today?
I don't have anything this week. I've been busy getting ready for the Global Summit and working on PCIe things. I would like to come, one of the next meetings with a little bit about the PCIe problem statement that we've been talking about a little, and see if we can maybe refine it to reflect the problems that we're all having. If that's okay with folks.
Yeah, I'm fine with that. One thing I want to maybe let's try to take a holistic view in terms of the OS interactions, ownership of PCI handling, error handling, that is, and recovery aspects. Those are some of the kind of tricky, sticky, especially EDPC as you start getting into RPPIO kind of things, or EDR kind of things. Then there's a I think those are areas that might be most beneficial to people. Just my thought.
Well, I guess what we're finding is that sometimes a UR is discovered by something, or sorry, is received by something doing discovery. In that case, we absolutely want to completely ignore it. The thing doing discovery will look for a -1 back from a config read or something. But the problem is that sometimes MMIO reads return -1s too, and a similar UR. And what if it's a DMA into an IO device and it sends a UR message? So, I guess there's a question of how do we configure the generic AR hierarchy? And that's kind of universal. Like everyone has an AR, they have root ports and endpoints and all the stuff in between. And almost all the time these days, it has AR bits that we can set. And so I think, part of the discussion needs to be, how do we set those AR bits in a way that works for OSs? Another part of it is, how do we take the vendor-specific response to PCIe messages in the root complex and manage that? And that may be something we have to handle in a vendor-specific way because, Intel has some things that are different from AMD and, different from some ARM PCI thing. But I think if we can talk about the outcome we desire, then we can have the vendor-specific discussions offline as needed, but at least we all agree on what we want in the end. So I don't know if that's the holistic view or not, though, Yogesh. You can steer me here, but my problem is we don't even know what we want for errors, and I don't really know what the errors mean half the time.
I think that's I like to hear others. I'll reserve my thoughts for some time, but I think we are thinking in good direction, both of us are. So Mark, Kramer, others, any other thoughts?
URs are a PETA.
I think that's the understatement of the century, Mark.
Yeah. Yeah, they're a constant pain. And I don't know that there's one answer that solves all the problems. I think the issue is there's too many ways URs can occur when they're benign, and too many ways they can occur when they're not benign. And that's the problem, right?
Yeah. And we don't know what to do. We don't know what to do about it. That's right. I agree with you, Mark.
Yeah, it's that ultimately the key is trying to figure out how to tell the difference, right? Because a UR from a device scan is just completely, I don't care. But if it's a UR coming from almost anything else, it's potentially a problem. And there's all kinds of side twists to that as well, because a UR response may come, and if you choose to ignore it, software may get all Fs and treat it as good data.
Yes.
So there's that aspect of it as well. And I don't think there is any one, global guaranteed that this solves all the problems. You just have to try to, solve as many as you can to make it as good as you can and hope that you don't get burned.
That makes sense. Do you think? I guess I'm hoping you still think it's worth working through here because at least I feel like we need help.
Well, I mean, nobody's going to argue that URs are not a pain point. I don't think there's anybody alive that doesn't know that. It is just been a constant battle. So yeah, I mean, it would be perfectly appropriate to spend effort here.
Okay, cool. Yeah, I like the way you put it, Mark, and I agree with what you're saying. So I think, and so I'll try to write some things down. I think we had the document, right? We had a PCIe pain points document, so I'll flesh that out a little bit more. I will put it in the chat window for folks to add to. And if people want to add to it, I would, that would help us. So I'll chat that in just a second. I'm pulling it up. Okay. Well, thanks. Thanks for letting me have a moment, Yogesh. I think that Anil is here now.
Let's say if anyone else has any other open, then we can switch to Anil's topic if that's okay. Some folks have just joined, so we are still collecting opens. If anyone wants to bring up anything else.
Okay. Well, and by the way, I did just paste in the meeting chat the link to the OCP pain point doc. It looks like Anil added one, so that's awesome.
Yeah, I just modified a little more and put a picture also, and I'll do more cleanup on this picture. I think this is generic enough. This is not specific to any specific vendor.
Anil, are you sure?
He's looking at the link that I shared, Mark. If you can click it, or we can share it.
Yeah, I can share. Or Drew, you want to share?
Yeah, I'll share. I've got it handy.
Okay.
I'm sorry. Is that okay, you guys? I don't mean to step on your plans.
No. I have no plans. I'm just asking everyone what should we, yeah. And
Okay, so this is the document, and Anil put a pain point in, which I applaud. Thank you, Anil.
Sure. I'm trying to put some more context here. Go ahead. Somebody speaking? Okay.
Yeah, I'm sharing. Can you all see? Is this okay?
Yeah, I can see.
yeah, I can see it.
Yeah, I'm trying to put some more context here. Basically, the key pain point here is that toward the right side of the picture, right? For all these three CVDs, as per the spec today, right? Either it can be routed as a MSI or SMI. If a hyperscaler wants to select one error type to be MSI, another as SMI, that is not clearly articulated in the spec, and implementation-wise, the implementation doesn't exist today. Like in the kernel AER driver, doesn't support that. As far as I know, I may be wrong here, but I could not do that based on standard distributions. So,
and also similar problem for even DPC flows is the system level control. Is not a port level actually. Like, hey, let's say you want to do for storage devices versus GPU devices. I did not come across like a port level or device type level control. I agree with you. I don't think
that is a very good point. I run into that, and I have to overcome that too. You're right. From an AER and DPC handler, because spec has not very clarified that, right? So from a handler point of view, once OS takes control, and let's say DPC control is to the OS, it's going to just start enabling DPC across all the ports. There is no mechanism to communicate. Okay, enable only of these ports, not other ports.
Yeah, that is the one of the big problems. Let's say, right, the DPC recovery to happen, you need to have software stack ready, right? The software stack may not be available for accelerator kind of devices immediately. That may have its own timeline. Whereas storage and networking, maybe those are like legacy devices. They have like better support. That is one of the pain points. I think I want to add it to this.
Go ahead, Rama.
Please add it, Rama. Make a copy of the template and add that. That would be awesome. And I think we need to consider not just eDPC, but DPC for switches.
That's what I think it is, right? DPC, which includes root port and the switch downstream port, right? That overall.
Yes.
DPC configuration.
Yeah, I can add. I think it's the same link, right? Anil is in the Google.
Yeah, same. Yeah. I'll just leave it here right now as a placeholder. Rama, go ahead and update this one.
Yeah, you can just add a comment like Rama to add.
Yeah. How come I cannot see you? I'll add here. Okay, don't want to spend time. Yeah. Okay.
Question actually, Anil and others, right? And I was trying to go through these pain points, right? Okay. Those problems are like, for example, underscore OS is part of ACP. Okay. How do we close the loop of solution? That means that we add it here, then we work with ACP spec owners, like a UFI forum to solve the problem, or how do we get it to become?
Yeah, that's exactly. We want to put the requirement here, right? And then if it requires changes in ACP spec, then one of us will take then lead to discuss.
Lead the effort.
Yes.
Yeah.
And I think, we're also considering proposing some changes to the upstream upstream driver for AER in Linux, and there may be that too. So, I would anticipate that we're going to propose changes to things, and we'll just divide and conquer, like Anil is saying.
Okay, yeah, makes sense. Yeah, we need to go and represent in UFI. Okay.
And Drew, just maybe to check something on what you just said, the thought would be that we have a, best practices document or something that we publish, and then if meeting that best practices document requires changes to other specs, we've nominated, individuals here to lead those changes, right? That was your idea.
Yeah, and like to Mark's UR point, maybe we can make the humble suggestion to the PCIe SIG that we need a different, we need to split up what UR means into several things so that we can say this one's serious and this one's not.
Yep.
Who knows?
Okay.
I don't know what's going to come out, right?
Yeah. Yep. No, makes sense. I think I just wanted to clarify, like, we do still need to focus on like putting together a document of some kind here, right?
Yeah.
Yeah. Okay.
Yeah,
And
I think we did one thing like similar thing, right? Previously, we defined a CPR, there is a Redfish gap. Then we worked with the Redfish forum, and they published the spec. I think similar thing we should do. I think from OCP itself, our team itself, there is a one success story. I think we should do similar thing.
Makes sense.
Yogesh, were you planning to have me present today, or there are other topics?
Just still collecting opens, but yeah, you did request last time that you wanted to share something, 15 minutes of time you wanted. So yeah, you can have that. Are there any other opens? If not, I have one, and then we can hand it over to Anil.
I'm trying to find out my other co-presenter. If she can join, that'll be awesome. If not, maybe we can defer it next week, or I can talk.
In the meantime, while you're doing it, let me share the changes that I made to the requirements document. And I just wanted to make it clear to everyone that the call to make Google as primary contributor on the requirements for the logo sake was mine and mine alone. And I did not get any request. I'm sorry if anyone felt bad about it. And Drew, apologies to you. You never asked for it. I just did it on my own. So this is the acknowledgement, and I requested to have cluster of logos like we saw in other contributions. Right now, the contribution is offline. As of the last meeting itself, it was offline. And I'll add this acknowledgement, and I want to have your feedback if you want to edit this verbiage. It's pretty generic, I think. So I'll let you guys read it.
Is this something new you added, or it was already there?
This is something that I'm going to add to, and this will be in the final requirements document that will be shared on the OCP website. So yeah, this is not there in the document currently. I'm editing it as we speak right now. I edit it. I wanted everyone's feedback if that's acceptable language.
Yeah, I think this looks fine. Just
Sounds good.
use the standard verbiage. Keep it simple. Do you want to kind of call out all the vendors, all the players name here, or I mean company?
No, I do not, because, and I'll tell you why. Because then we'll get into everyone going back to their companies asking for approvals, and I don't know if it's worth the pain to go through all that. If someone has a strong desire to do that, we can tackle it in later. And I think that's just waste of time to delay, and that's my opinion. But if
Yeah, no, that's okay.
Strong, we can.
Yeah, I concur. Yeah.
Okay, then if there is no other feedback
Actually,
on this.
I have one something that I was planning to bring up today. So
yeah. So I was just going to say, Anil, I'm going to stop sharing and hand it over to you. Okay.
Actually, leave the share here because I have it open associated with this document.
I see.
So assuming this goes public, I mean, on the website today or next week, what is the plan to further enhance, update as the next rev of this document? Or should we work on it?
What is that we have right now to edit it with, or I mean, we can version it. We can create the next revision of it. Those are two options.
It is version. We should probably just save off a PDF and keep editing the same document. And we did freeze a version in the list. This is one.
So just to disambiguate terminology here, Drew, maybe we think and see and think about versions differently. But if we have a revised version of the document, right now this document we are calling it version 1, but it's really what we probably want to say is revision 1, and when we have next revision, we may have totally new content in it. Now versions, we have several interim versions to get to the final version of this revision. Maybe I'm overthinking it, but I just want to have a little discussion about that. I was thinking if we have a substantial amount of content, we'll call it like, okay, revision 1 point whatever. Maybe there's no difference between the version and revision, whatever everyone agrees on.
My goal is just keep I like the URL that we work on to stay the same, and we don't really have to change the URL. All the versions of the document are in the history, and we can save PDFs off when we want to publish it.
So URL is only for our interim purposes and editing it. When it goes contribution, it goes as a PDF.
Yes.
So URL does not matter at that point. We can continue to work on this document in the Google Docs and keep having, the software version of it. We can see version history here, and we have several versions here. We are calling this 1.0, but really we have a lot of versions. So what I was thinking is when we have the maybe substantially new content or changes in our thinking, we can say, okay, in this revision, we'll have a change list. In this revision, we changed it with this and this major changes, right? Edited the document. And that would be a major revision that will be published again on contributions website. Does it make sense?
Yeah, it does.
So basically, you will change the file name from 1.0 to, let's say, 1.5?
Yeah,
Yeah.
something like that.
When we have 1.5, sure, why not?
Okay. So here
In fact,
is
I think we should have the number in not just in the file name, but also in the title somewhere. We should have that information here.
yeah,
somewhere.
I agree. So call that 1.1, 1.0, right? Because that's what we all agree. Version 1.0, and then keep this file as it is. PDF goes public, and this Google Doc stays as it is, and then create a 1.5 version, which will start adding comments and further
Well,
edits.
That's why I'm saying, do we really need a new doc? Can't we just edit the same doc?
No, not a new doc, not a new doc, Google. Sorry, Drew, same doc, same Google Doc, but just
Okay, that's fine.
We'll make a change here. I don't think we need to make a new doc on it. It's very cumbersome to manage multiple copies of a doc.
Okay, that's fine. That's fine. As long as we can disambiguate what was published, right?
Yeah, I think what we'll have to have in the next revision, we'll have a change list. So when we release it to contributions, then we should have identified why we are doing this, what is new from the previous one, so people don't have to sift through the whole document to know why we have to read a new version of it, right?
Okay, makes sense. So with that understanding, sorry, go ahead.
One quick comment is like,
good. Go ahead. I'm sorry. I was just saying, sounds good.
Yeah, I think what are the goals for 1.5? What are the things we are trying to
so
add?
let me clarify. Yeah, let me clarify a few things. So I reviewed this document, by the way, the one which actually went out on the website also. So what I'm finding right now, there are few places there is an inconsistency. Okay. And a few places there is a ambiguity in terms of what we are saying. I didn't want to add any comments or edit anything because I was still waiting for this to be published and also discuss here how we want to add the comments or provide feedback. So now we agree that we will just continue this. I will go ahead and add my feedback, and let's make policy that nobody will just edit it, you'll just comment it first. And then just like we did before also, right? And then either offline we can agree with that other folks, or we can bring it in this Friday meeting and then review it if it requires broader agreement.
So that sounds good. What's next? I mean, like, what do you have in mind, Daniil?
So I think there are a few things that I found inconsistency in the document. I want to make sure that we at least clean that up for the next release, next version.
Okay.
One big ticket item that I saw here was that in the very beginning of the document, we talk about the in the scope versus out of scope. And in the scope, we talked about, we are saying out of band error management. And then as I start reading it, it kind of goes into in band also, and then talk about in band, in some part of in band as well. So I got lost in that whole thing. So we want to make sure that we kind of keep that consistency in our messaging and the scope instead of scope.
Yeah, one thing I thought you were going to do is go drive some in-band stuff, and we should fold that in here, right? I mean, or figure out how to incorporate in-band into our thinking. I'm not pushing back. I'm just saying we need to go do the work, and we need to write some stuff down, right?
So that's a very good point. Next follow, right? So I was trying to bring it here. So for the in-band requirements, should we roll up into this document, or should we just create a separate document and then tie it to this one?
I think we need to start reviewing what is that requirement, and I think people have to, like the process we did last time, right? We can work on this document together and start reviewing it, right?
Sorry.
I don't understand if you need a new process. I understand what you're bringing in is in band, and yeah, we'll have the same discussion, same document continues.
Okay, so you're suggesting to just. Sorry, go ahead.
No, I just wanted to, it's not just my opinion. I want to have others chime in also if that's a good approach. I think it is, but everyone else can chime in.
Yeah, no, I want to make sure that I understand your input, right? So you're saying that let's keep the same document and append it or edit in-band method requirements also here, rather than creating another.
So I think yeah, I think so. So so first step for in-band was you were collaborating with cloud service model folks and working on use cases that make sense for in-band, that we need for in-band, and then I think next step is how they translate into requirements, right? So that's when we start discussions and start editing.
Right. One comment on that, like at a bigger scope, are we trying to have a parallel implementation for every fault, or only like in band, or only where it doesn't make sense out of band, where we are trying to cover in band? What is the approach we are trying to do? Like
at the high level approach is later say where it makes sense to put the requirements for in band, and where it doesn't make sense, we won't put that, because clearly in band not all error types are possible.
Okay, I like that approach rather than like parallel implementation, because then people will get confused. The people are asking for like both the requirements and then quality of implementation. I like that approach. There, like upper band doesn't make sense, right?
Yeah.
If we can define that area, otherwise, yeah, that way it is like we are asking same requirement, simple implementation, and
yeah, I mean, if you scroll down in this document, right, and Drew, you are sharing, right?
I'm sharing.
Yeah,
yeah. So if you scroll down, we talk about the deployment model, right, and then we immediately zoom into the bare metal, and that becomes like a focus of this document, right? And so we can continue to use the same theme and append it. Okay, if it's an application use model, then how does error requirement look like? And some of them will be used. Go ahead.
And you have your, so I'm gonna make a plug here. Anil has a talk for demystifying in-band and out-of-band error logging. He talks about the usage models that we have here. And I propose that we use some of your material to factor in the in-band into this document and the rationale for it.
Yeah, I'm perfectly all right. That's what I want to get a clarity what is the right way to build the 1.5, right?
Oh yeah, that was more to everyone else, not you. I know you knew that, but I'm just giving an advertisement for your presentation.
Sure. Any other input from the team here? Yeah, so this is the diagram I was referring to. So Yogesh, that you're showing, right? So from this diagram, right, then rest of the document talks of stay focused on the bare metal use case and how the requirement would look like, right? And as the next 1.5, we can say, okay, now let's talk about application and infrastructure use model. How would the requirements, what are the differences in the requirements, right? Some will be common and there will be some differences. So let's describe that.
So So I think, yeah, that was our intention, right? So we did say that this proposal focuses on out of band, and we'll adopt in band in next future. We said a future work stream. I think that might be that's I think okay. Do you want to?
Yeah. No,
it sounds
we
like
have to make
different.
we need to make some changes here, right? We want to be very explicit, right? That the future version of this document will include InBand as well for other use models.
It says right. This proposal will be adapted to InBand. But only thing is we are doing it in just this work stream, but kind of maybe we don't need to go into this. We can just delete this part in a future work stream.
Yeah.
Or maybe future versions.
Yeah, future version is fine.
Okay. So I think we are in agreement with this change. I'm sending this document to Rob to release on the contributions portal. And we have an agreement that yes, we will use this document. We'll have the lively debates and discussions as we did for out of band for in-band also, and we'll continue to pave the path forward. Okay.
Perfect.
Now, Anil, you wanted 15 minutes. You have about 20.
Okay, the presentation actually is for half an hour, but I don't want to go through all the slides. Allow me to share now. All right. So this is the presentation I am myself and one of my colleagues are planning to present at the OCP. Grand Teton platform is one of our Meta's next generation of training cluster. And the scope here is to talk about, share some of the knowledge and learnings, how we implemented PCI anchored error handling solution. So I'll not go through each and every slide the way we're going to present, but I'll just kind of share here and get some input from the audience here, because you guys have a lot more knowledge base and insight in giving good quality input here. So the scope of this whole presentation is to first go through the AI/ML cluster, how it looks like, and then zoom into one of the node and discuss the various fault domains and stay focused in the PCIe domain only. And then what kind of error handling solution, error handling requirements and implementation we have considered, and some of the challenges that we faced and how we overcome it. So at a very high level, 30,000 foot view, a cluster is a series of racks or a bunch of racks together, including storage, networking, and compute. That's is shown. This is the research supercluster that Meta has released a few years ago, actually, and now we are working on the next generation. Right inside is just a pictorial view of really like how a data center looks like with this kind of cluster. And if you just zoom into one rack, it looks in the block diagram level on the right hand side. Each of the module, so there are two modules or two chassis in one rack, and each of the chassis includes the 3 trays. The top is the CPU tray, the middle is the IO tray, and the bottom is the GPU tray or accelerator tray. So the CPU is a head node that is used to ingest the data And then the IO tray is to interconnect multiple racks to build this large cluster, thousands and thousands of these nodes together. And the bottom one is where most of the computation happens, the training of the training models computation. If you just zoom in into one PCIe hierarchy, there are lots of devices, even though logical and pictorially it looks like simple, but it's a pretty complex three level deeper PCI device hierarchy that we need to support. And a large PCI device hierarchy means increased platform failure blast radius also. Any component failure or error detected need to be handled properly, especially for uncorrected errors. Otherwise, machine will crash and the whole cluster application crashes. And the uptime point of view, it looks quite ugly. So we need to make sure that all various uncorrected errors are handled appropriately and contained so that the rest of the cluster is still operating successfully. So what are the different fault domain or failure modes that can occur within the PCIe hierarchy? So simplified view on the left-hand side, all the way from CPU root port to the PCI switch, upstream port, downstream port, and then the device. On the links itself, the various kind of fault that can occur is like a single bit flip on the link, single bit or multi-bit, but bit flips. And the second is like a bus level fault or protocol errors. And the third bucket is internal errors, which are not specified in the spec, but internal errors can happen as the data travel from this root port to the end device or end device to root port. So as per the spec, PCI spec, there's a pretty robust fault coverage already defined and implemented for bit errors. And most of them are actually correctable. For example, receive error and bad TLP, like CRC mismatch, LCRC, all kind of replay timer timeout concepts are being implemented to make sure that any kind of bit flips are handled appropriately. Then when it comes to the bus faults or protocol error, that's where most of them becomes uncorrected error. And some of them are non-fatal, some are fatal. And this is all programmable. Spec defines that. And it's not that straightforward to decide which one is non-fatal or fatal. So we go through that process of deciding which one. Right now, this is the spec defined categorization by default. So things like unsupported request, completion timeout, ACS violation, or poison TLP, either egress or ingress, these are all non-fatal. In our fleet, we have changed in this AI ML cluster, we have changed some of the severities. Like for example, completion timeout, we call that as a fatal error. And when it comes to these bus fault, which is actually uncorrected errors, one of the technique that is we are explored, and we will go deeper here, is the DPC, downstream port containment. Because we want to make sure that any type there is an uncorrected error detected, whether from the device to the switch or from switch to the root port links, the impact of the uncorrected error stays as close to where the fault is, rather than bringing down the whole machine. And then the internal errors, which are typically uncorrected errors, like a bit flip in the data buffers, intermediate bit data buffers. This is where this feature called ECRC, it becomes very, very relevant, and we have considered it and enabled this feature because the switch may have this own buffers and the data stays there, and any bit flip there, it will not be covered through the PCI spec link integrity checks. So ECRC feature helps it. And here, this is a pretty standard spec-defined fault coverage for bit flips, all the way from physical layer to data link layer to transit layer. Nothing exciting except this all spec-defined. Now, let's talk about the uncorrected error implementation. So I'll just go through one example. Yogesh, are there any other topics today? You want me to just flash one example here and then close it, or?
There's no other topic today.
Okay, so let me just walk through that. This would be useful. So on the right hand side, what I'm showing here is illustration of a one hierarchy. So a NVMe drive as a device to the switch, purple box, and then CPU with computer and memory with a root port. And on top of that is the platform specific handler, which is basically SMM handler, and BMC for out of band. And on top of the stack is the OS with the AER DPC driver and the device driver. And on top of that, actually, top in the sense like the additional software stack is our DC tooling. One of the simple example is, let's say PCI uncorrected error is detected at the switch downstream port. And in this case, NVMe drive, right? Typically, NVMe drives in the industry or the drivers for the NVMe drives do support hard plug. And therefore, we were successfully able to implement containment as well as recovery for various uncorrected errors detected between the link between the drive and the switch. So one example is surprise link down. So let's say if surprise link down is detected between the switch downstream port and NVMe drive. So in this case, the switch downstream port will detect that error and trigger DPC. And then update the DPC status and then send an error correct message to the root port. If the DPC is not enabled here, then it would have become a fatal event and would have crashed the machine. So because we enable DPC, this becomes error correct message and goes all the way to root port. In the step number 3, root port handle this message. Basically, it invokes SMI, SM handler. And the SM handler in the step 4 cross through the hierarchy and finds where this error came from. And I'll say, oh, switch downstream port detected DPC. And DPC status and AER logs are captured. Then the firmware is going to send a message to the OS for AER DPC driver to unbind the NVMe driver, which is running in the software stack. So once that, and since the driver supports hot plug, is going to successfully unbind. Therefore, driver now knows that something went wrong and the device is not available. And once that is successful, then OS is going to, in step 5, OS is going to clear the DPC status. And that will trigger link retraining. the link between...
Hey, Neil.
Yeah.
Just out of curiosity, what does firmware do in step 4?
Sorry, I skipped that part. Step 4.
What's the notification? And by the way, I think you meant link is retrained, not link is retained in 5.
Oh, this is spelling.
No big deal, just minor spelling. I thought you'd want to know.
Retrain.
Yeah,
is missing there. Thank you.
So what is that firmware notification like? I'm just curious.
You mean from the CPU to firmware or firmware to the OS?
The second sentence of bullet 4.
Firmware sends a notification to OS. So this is the SCI interrupt.
Yeah.
Sorry, go ahead. Somebody's asking.
Well, I think I can explain this. So for DPC, this has to be a collaborative effort. Even though we are in firmware first, the platform is not capable of doing recovery completely by itself, right? So this ends up being a collaborative implementation. It's negotiated at boot time. So the platform knows that the OS is DPC capable because of an OSC exchange. And the OS will essentially ask for DPC support on a given link, and the platform will grant it and then configure it. So when a DPC event occurs, the platform will be aware, be signaled, but then will ultimately hand everything over to the OS to, essentially recover. So the device will be, unmapped, a new device
Yeah.
plugged in, and then the OS will program, and then at the end there's supposed to be a call back, back to the platform, so the platform can, do its cleanup. But ultimately this is, essentially a collaborative implementation between
But
the
is it
OS
a
and the
HEST?
platform.
Like, is it the HEST or is it just an SCI for that notification?
Yeah, I think it is just an SCI. The idea is the error correctable will be tied to SMI, and that will notify the platform, and then the platform will send an SCI to the OS to make the OS aware that there's been a DPC event.
Yeah.
Okay.
I could make it, I could say in step 4 firmware sends SCI. I just left it generic notification. Yeah.
I vaguely recall that it's selectable. It's not always an SCI, right?
Yes. In our implementation, we are doing SCI, but yeah, that's why it's a generic term, right?
Yep.
Notification. It could be,
Yep.
yeah, NMI could, I mean, for all the matter, it could be NMI also, but obviously,
Yeah.
I don't think anybody wants to do NMI here. I mean, in general, for uncorrected error, we do NMI, but in this case, because this becomes a correctable message, therefore, we in our implementation, firmware or SMM is going to send SCI.
Well, I was just trying to figure out how the firmware communicated to the OS. Hey, I had a DPC, go do something. And so is it the particular SCI or that tells it that, or does the OS get an SCI and just go look around and go, oh yeah, hey, there's a
There's a protocol defined there, right? So the call SCI and there's a GHES record is the one that AER handler reads it and say, oh, this is a DPC event. Let me pass it on a DPC driver, and the DPC driver takes over from there.
Yeah,
Okay.
it's the latter, Drew, right? I mean, the OS registers this as an interrupt source at the time of the OSC handshake.
Yeah.
Got it. Thank you. Just trying to figure out, learn from you all how it works. Thanks.
Yeah, sure. Yeah. So in step 5, right? This is where because OS already in the very beginning negotiated, and DPC and hot plug are OS in the OS control, whereas AER is under firmware control in this implementation.
Got it.
So the OS DPC driver is going to clear the DPC setup because that owns that, and also and of course unload the driver or unbind and send the response back to firmware. And as a part of the DPC status clearing, the link gets retrained, and then firmware does the rest of the cleanup work that as Marco just mentioned. In step 6, firmware captures AER logs from downstream device, identify the surprising down event in the AER log also on the device side also, to just make sure that this was actually SLE detected. There is no other error that caused SLE. So sometimes there could be cascade effect. So firmware capture that. Now, as a part of this link retraining, once the link gets retrained, the device is now acts like will trigger a hot plug or hot add event because the presence changes, present detect, and that because the OS owns the hot plug as well. So this hot add event goes all the way to the OS, and in step 6, what I'm showing here, and that at that time, OS is going to reload the driver, basically reinitialize the whole stack. And that's how this MIMI drive will be now again visible to the upper layer of software stack. And the step 7. So now one thing that I didn't say, but it's written here, is that the firmware is actually, when the notification comes to firmware, it also saves the data to BMC. So the DC tooling, which is running on every machine, periodically polls to the out-of-band method, the BMC cell logs, and say, oh, I see an uncorrected error and I see a DPC event. Let me trigger a remediation repair flow. And in this case, we have implemented that, okay, if there was a surprising down, even though system did recover, but there is always a possibility that at the application level, something might have still crashed because there was interruption. So it is still considered at the application level as an interruption. So our tooling will say, okay, I'm going to take the machine gracefully down. I'm going to reset the whole machine and then make sure that there's nothing else wrong. And once that is taken care of it, then I'll take the machine back into production. So that's how this whole flow would look like when such error happens. Yeah. Mm-hmm.
Have we enabled this DPC and recovery flows for other devices like the accelerator, or only for storage? What about the network and other?
Very good, very good. So that's the second example. So now in the second example, let's say in this case also I'm giving example NVMe drive, but I'm also including now a OEM or GPU device. Okay, so this is a little more complex example, and here the containment is implemented, but recovery would not be possible. And let me explain what happens, why. So in this example, the failure actually was a firmware, NVMe drive firmware corruption itself on the device itself. Okay, it's not the link issue, the firmware. So that results into this NVMe drive failed to respond to a non-posted read. And that
By the way, not to be too pedantic here, there's a typo there. It should be failed to respond, right? Not failed to response.
Fails to respond, failed to response. Okay, good. Failed.
No big deal. Just thought you want me to point out the.
Yeah, no, that's good, good. Failed to respond. Failed to respond. No, failed.
It's response.
Respond.
Yeah.
Yeah.
No, there you go.
Yeah. Thank you.
You got it.
Yep.
Yeah, no worries. I hope you don't mind me pointing that out.
Yeah. You can see English is not my primary language.
Well,
Grammar mistake.
You're doing great. I just saw, yeah, thanks.
Yeah. By the way, we are at top of the hour. You want me to continue?
Yeah, continue on it. Yeah.
Go fast.
Minutes. This is interesting.
All right, let me go fast. Yeah, so in this case, because of firmware corruption, right, there'll be, so for non-posted transaction, right, there'll be complete timeout at the CPU root port. And that complete timeout at the root port will trigger a DPC between the root port and the switch upstream port. Okay. Now, this actually is a more complex problem. First of all, in this case, there will be a RPPIO. It is enabled, so this complete timeout will be logged there with the header information. So that we are relying on that. This is a E part of the EDPC that we have implemented. And rest of the flow pretty much goes through the similar way as we just talked about it, except when it comes to the OS, OS will try to unwind because the link between the CPU and the switch went down, therefore all the devices behind this root port are going to get impacted. They will not be visible to the software stack. So OS will attempt to unbind all the drivers, in this case, NVMe and the accelerator. But accelerator doesn't support hot plug, or doesn't support unbinding concept. Therefore, it will fail. Unbinding of the OM driver will fail. And as a result of that, the link will never get retrained because the DPC status will not be cleared. OS will not clear that as per the spec. So in step 6, in this case, what happens is the response will come back to the firmware saying, hey, there's a failure in binding. Now, firmware's responsibility is, in our implementation, will clear the DPC status in step 6. And as a result of that, we expect the link to retrain so that the devices now are accessible, and firmware then capture the AER logs from the wherever the error came from. I mean, in this case, the root port. And it'll also be able to capture the device information. And in this case, the device will not be, even the link is up between the NVMe drive and the switch, but device will not respond. because the firmware has problem there or crash. So the rest of the DC tooling will then come in because we got some cell logs, and we'll apply again the remediation repair rule. And we have hard coded that, okay, if there's any drive, then must be the firmware, and therefore go and reflash the firmware. So we
I have a
even though
question. Oh, sorry. So I have a question about this, if you don't mind. So like with a timeout, you don't really know who I mean, like in this event, you presuppose who caused it, right? You said this is the cause, but you don't really know that at the moment, right? All the root port knows is I asked for something, I didn't get an answer, I'm triggering a completion timeout. How do you know who did it, whose fault it was?
Very good question. So RPPIO is the enhancement part that is added, okay? And RPPIO actually does capture the header log. It not only captures what type of transaction is a configured, what kind of non-posted transaction is a configured or memory read or IO read, and also the header. So that header is the magic here, okay?
Yeah. No. I've been talking to people about wanting PCIe headers for errors. I get it now. Yeah. At the end of the day, we want to know what BDF was the problem, right?
Exactly. Yeah. So we can get to driver, right? And we can get to the clearly that which device did not respond, right? And now what caused it? This is where our heuristics comes in here in the step 7, because most of the time when device doesn't respond, we know it's a firmware issue. So we go and reflash the firmware, try it again. I mean, first off, machine tech goes in repair in this case, and then reflash the flash firmware. And if that doesn't solve the problem, that means it is really a hard problem. I mean, a hardware problem somewhere, or something really bad that requires a swap, and that triggers actual repair to take this drive out and then replace it with a new one. So net here is that in this particular failure scenario, we achieve the containment because we did not retrain this link until the firmware came in just to collect the data, and then actually the firmware will again put this link into DPC in step 6. I missed calling it out. So we want to make sure that the link stays in the containment, and then take the machine, and then take the rest of the machine down. So there's a gracefully taking the machine down rather than abruptly crashing the whole machine, all the software stack. So that's the.
Like in this case, Anil, without a DPC, in this case, let's say you don't trigger DPC. Okay.
That would have been an uncorrected fatal error, kernel panic, and machine is not reachable. We won't even know what happened, and the machine has to go through reset. And by the time all the errors are gone, we will just know that machine crashed for some reason, whatever.
No. Let's say if we have the OS handler, right? OS handler will read the log.
If we can make this as a non-fatal, yes, then kernel panic will not happen, and then OS will be able to read the logs. Yes.
No. Even in the fatal case, before they generate, let's say, like NMI or something, right? Crash, right? They'll go and read the log.
No. If it's a fatal error, Ramo, then there'll be NMI, fatal NMI, at least in our implementation. That's what firmware will notify. And as soon as NMI is received, fatal, kernel will panic right there. There is no other handler, like a DPC AER driver is not going to run at that time. It won't get a chance even to run that.
Oh, what you're saying is NMI handler will like immediately.
Oh yeah. Immediately take the kernel panic in the panic state. Yeah.
Yeah. See, I don't think people.
Yeah, but hold on. I'm with Rama on this. The NMI handler knows that the PCIe, like there should be a HEST error as one of the NMI sources, and it should go check that. And once it sees that, then it might panic, right? But it should be able to do something with that, right?
So yes, it can. I'm not saying it should not, it cannot, but this is how it is off the shelf implemented, right? The Linux NMI handler, this is how it is implemented. I mean, we didn't make any change, and this is what our observation was. Now, somebody can modify that.
Yeah, I mean, I'll just say there's something. It doesn't obviously panic on every NMI, right? There are plenty of non-fatal NMIs that get issued, right? So it has to know that it's a fatal NMI, right?
Exactly. That's what I just said, right? Complete timeout. If it is if it is configured to be a non-fatal error.
No,
then-
sorry, that's not what I'm saying. I'm saying like a typical x86 processor can issue NMIs for like performance counter events, right? Like things that are completely benign. The NMI handler in Linux goes and looks for those sources, and then only if it, doesn't find those and finds something fatal will it kernel panic, right?
And we've NMI'd ourselves to death with PCIe errors because the OS got too many of them, not because it got one. So that's what we have to figure out. I mean, that's why I'm scratching my head too. I'm not pushing back, Anil. It's just, how did we figure out that this particular NMI was fatal? Because the NMI doesn't have that inherently. It's just an interrupt, and somebody has to go decide that it's fatal.
And then my handler will go through.
Because we are implementing firmware first, right? So from a hardware point of view, it is still SMI. And then firmware says, oh, CTO is configured as a fatal event.
Yeah,
right?
I'm just saying the Linux NMI handler has to have determined why it got the NMI, or it didn't see a source of an NMI, and then that's what made it fatal, right?
Right. So in this case, it will determine, because this NMI that is sent by firmware will have either fatal in the record, right? It's because NMI handler will read the record and say, oh, this was a fatal event, and source is from the
And I think Rama's point was simply, given that the OS at that point has the error record, it presumably also puts that into the console or the system event log at that point, right? No, sorry, not the system event log, the system log at that point.
Yeah.
Right.
So if somebody can find either change the severity to non-fatal, right, for community timeout, then kernel will not panic, and NMI handler will read that, and then from there onwards, we can have the AER also running. AER actually handler it'll pass on the AER handler to decode the rest of the thing, right? And then machine will not panic.
Well, and Anil, can't you also like let it be a fatal error? You machine check, but you do a warm reset, and the BIOS logs whatever error it saw in the BERT on the reset.
No, that won't work, Drew, right? Because the BIOS has seen the hardware state, created a HEST entry in memory, and cleared the hardware state and sent an NMI. So the error in the hardware state is gone, because from the BIOS perspective, it's still a runtime error, right?
No, well, I'm not sure that's all true, Vilas, but let me just say I think this example is extremely ugly, right? When you get a completion timeout, there is all kinds of variables that come into play. And particularly, if the device times out, often it's because the device stopped responding. So the possibilities then get, magnified, because I might not have any credits to be able to do any requests to the device. So there's no guarantee that at that point the platform can actually collect any data, right?
That's a good point too. Yeah, community timeout is a very ugly error. So let me kind of come to the next thing, by the way. So because of sorry, go ahead.
I was going to say, this is a completion timeout at the root. So I agree with you, Mark, right? But this is a completion timeout at the root port. Gathering the information doesn't require going to the device, right? It's all in the root port.
Yes, but if the device has stopped responding and there's lots of requests pending, then credits may have backed up all the way to the cores.
You got 3 strike.
Yep, you can't guarantee.
Not with DPC. So DPC completes anything that's outstanding.
Yeah,
I understand in general.
I think the discussion was that if DPC is not there, that's what Rama raised the question, right? If you don't do DPC,
I see.
can you still implement a solution, right?
If you don't do DPC, then yes, that's absolutely correct.
Exactly.
But I would just say is the way this typically works is either the platform is successful and then passes the event to the OS, and that assumes code execution is possible and feasible and succeeds. Now, if it doesn't, for whatever reason, and there's a million reasons why it might not succeed, then the platform crashes and the information is collected after reset.
After a warm reset is what I was thinking. Yeah, I'm with you, Mark.
Yeah. So let me kind of finish the thought process, right? So this is the example where we were able to successfully determine the source, but whenever the CPU root port that link triggers TPC, for various so many other failure scenarios, we may not be able to detect where which device really the problem started from. So enabling DPC at the CPU root port became a problem for us, actually. Even though containment.
Yeah, you should know which port, right? Because the port that was transitioned into DPC you will know. The problem is if you have multiple devices below that, and you knowing which specific device below that might be difficult, right?
Exactly. That's exactly the problem, because we have a hierarchy, right? So therefore, let me kind of go to the next thing that what we did. So we decided to not enable DPC on the root port, okay? Because that becomes a problem for us because there are lots of devices behind this. We still maintain the DPC on the switch downstream port because that was pretty clean, point to point. And we did enable RPPIO because in case of this case that we looked at example 2, completion timeout, we will use RPPIO to determine which was the end device. But because DPC is not enabled, we will just basically crash the machine. So that's how we implement it. So containment is still there, but then after that, there's nothing much we can do except finding out where the problem started from, and then take it down immediately, and then go to the.
How is containment?
Sorry.
So containment is maintained for the devices, but not for the switch, right? The switch
Correct.
has a problem, then you don't have
Correct.
containment, right?
Rama has his hand up.
Yeah. One question. Like I am thinking through the user, like this right now we are cluster, right? We have done all this, right? Even the 3 examples, right? Thank you first, Anil, very detailed. The workload wise, right? The training workload wise, all 3 examples got interrupted because you sent the node to OS. Like it loses GPUs basically.
Yeah. So in the example 1, at the node level, we were able to recover the node, okay, without crashing it. But at the application level, there could still be an impact. Therefore, we will gracefully take the machine down. Gracefully, that's a very important part, right? And we know exactly what to do. So we got all the visibility, observability, everything is successful here. Whereas in the case of example 2, there are many ways the failure can happen where we may not get that clarity. Containment is still there because this machine is not going to do anything now. The root port link is down, right? So various drivers behind this link is going to start complaining, and application will just crash. So we will prevent any kind of data propagation. So containment is maintained, but that's about it. There's no recovery possible here in this case.
Basically, you're able to act on the poison kind of data, like immediately contain.
Correct. Exactly. Containment is maintained. Think about it. If the CTO event happens and we don't bring the machine link down, software, and let's say this is a non-fatal event, software will continue to operate because this CTO event will do master board, right? So software will assume that is a valid data, all one, right? And that could have all kind of data corruption impact. So we don't want that.
Right, but that's an option, though, Anil. Right? You can choose to return poison.
Yeah. If the DPC is enabled, but
your example is still perfectly valid in that either way, I think your application is dead, right?
Mm-hmm.
And so a reboot is a wise thing to do at that point.
Yep.
But I was just curious, as you have the option of returning a UR or returning poison.
Yeah, we didn't went to the poison because then that will require some more modification in our stack, right? Or rather, I would say that poison event will then do a machine check, and the machine check has a different our tooling implementation. So we didn't want to go through that little more complexity. But yeah, that's a good point, though. We could have enabled poisoning, but this is all based on the DPC flow, right? If you don't, I think the question I'm trying to again answer what Rama mentioned, right? If you don't enable DPC, sorry, my bad. initially we did the DPC, but now we decided not to enable DPC, right? So we just don't have any choice but to crash the machine.
Yeah.
In this case, DPC are controlling at the root port, like silicon register level.
Yeah. Now, just between us, right? I do want to get to at some point in future to re-enable the DPC or the CPU root port also. And again, the reason we decided not to do it because we ran into so many problems with the GPU. Okay, I don't want to make it so public here. Okay.
Yeah, I can second your pain. So if I follow it, yeah.
Right. So therefore, we just completely lost the visibility, observability into the machine once this driver starts behaving differently, and that was just no for us. So
And
I think we are all facing similar problems. I think that is really good.
Yeah.
yeah.
so
Exactly.
Adil, but you also address that problem by guaranteeing that your devices were all point to point below your switch. That way
That is
you,
correct.
that way you had your isolation. Right?
Correct. So yeah, so I mean, we are able to maintain the isolation with this approach. What we have, if there is an error occur between switch and CPU, right? Then we will have to crash the machine. We can't do any further containment there. That's the loss we have right now.
Yeah, but I think that's a much lower probability than the device
That's correct.
side.
That's correct. Yep.
Yeah.
You're absolutely right. So we are okay. Not a like bad. It's not ugly, but it could be better. Let's put it this way. Right. We
No,
want
it
to build
seems very well thought out to me.
Yeah,
Thank you.
thanks, Anil. This is really interesting. I think these are, but this echoes some of the pain points, in PCI that we need to talk through, right?
Correct.
Yeah, this actually could be a case study in the pain point that you're facing, and you're placing it as a solution that you have, but it's actually there's a gap there. That's why you had to do the workaround. Kind of, it's not ideal coverage that you could be in this
there
kind
are
of
few other gaps, by the way, which I'm not pointing out here. We are very vendor specific. They're even much nastier. That's why we need to work with vendors to solve those problems. Like this example, which I skipped it, by the way. I'm not going to share this one. This is the example that actually amplifies one of the vendor issue. So I'm not going to share that in the presentation in the OCP. So anyway, the key message is here that key learning, right? DPC is required to prevent any data corruption, right? That's given. We want to use it, and we want to encourage other hyperscalers also to consider using the DPC wherever possible. And next thing is recovery may not be possible for all the uncrypted error types. So
when you say recovery, you're talking about OS recovery or device recovery? Because I could see if I have 100 accelerators attached to one machine, I could see shooting one and continuing to run, and then when I get around it, I can replace the one that failed.
And that is what is not possible today. We would like to get there. So that's what I'm calling recovery. Recovery in a sense. Sorry. The first thing is I can contain one GPU and keep the machine running, right? So that's one part of the scope of the recovery. And the second part is where if I can even get the GPU that had it maybe transient error due to transient event, if I can restart the GPU and recover,
that'd be a miracle. Yeah, that's like the dream.
Right. But today I can't do either. If GPU has a problem, the whole machine goes down here. And the whole cluster, the application crashes right there.
Well, when I said you could lame an accelerator, I meant it in a more generic sense.
Yeah.
Basically, like I don't know, like if we have how do you contain to accelerator level, because you're bringing down the system with NMI and other things, right? How do you contain
NMI, it? If I don't enable DPC, then yes. But if I use DPC correctly, right, there is no NMI.
But because
NMI into the world either, though. That's another point, Anil. Like NMIs don't always crash us.
Yeah. I mean, I'm saying that with the DPC, we have a very very precise at the transaction level control at the hardware level and then the rest of the software stack if I can successfully unload the driver. I think the gap right now I have is I cannot unload or unbind the GPU driver.
Yeah, yeah.
Okay. If I can do that, then all bets are off. So that is something we need to solve the problem.
Yeah.
So that brings us to the third bullet, right? DPC is a complex feature involving hardware, firmware, OS, and drivers, right? And at a system level, I should say design and validation required, keeping end-to-end flow in mind. And that's what we did, and we found failures. We didn't deploy. I mean, before deploying this cluster, right, we disabled DPC. Otherwise, this would have been disaster for us. So as a result of the validation,
one question, Anil. Sorry, Yogesh, go ahead.
Go ahead, please.
Yeah. Right now, you're like enabling DPC at a particular port level and deploying the systems. Is that correct?
Correct. Yeah, and that brings us to the point that you mentioned earlier, right?
Yeah.
As per the spec and then implementation, we can't do that if I just use off-the-shelf Linux driver and all that. So we customize it by selectively enabling DPC and making sure the OS doesn't come and override that.
Yeah.
Oh,
right.
Okay.
But I think
you
it's
have a change in the OS also for that.
We have to make the change. Yeah.
Well, and that's something.
It's not OS. It's not that we change OS. We did through our tooling, right? We override things.
Yeah,
you can have PCI quirks and all sorts of things, but I think we should consider, what we want to do with like the AR driver and how to extend it to make some of these things a little less painful for ourselves.
Yeah. I would just include, the point that you were able to get to that configuration because you actually did the isolation on the switch. So now you have the ability to individually remove a single device without affecting the rest of the platform, right?
Yeah.
Both of those things are necessary.
Yeah.
Right. I think the point that
I want to call out.
Yeah. The point I was making, Mark, that when we initialize the machine, right? Once we say DPC is enabled, right, as a platform feature, then current implementation is the DPC gets enabled everywhere. All the switch downstream port, root port, everywhere, right? Now we have to go and revise that by disabling selectively on the CPU root port. That's a custom solution for us.
Well, you can do that with things like PCIe quirks, and so that's where I think we need a better solution in Linux, and maybe something, as we're talking about farming out improvements, maybe that's one of the improvements we farm out.
Yeah. I think one thing I can call out. I know we are running out of time. Like Anil, see the
We're out
interest.
of time.
No. See the interest we have, right? I would say, like, before we work on in-band thing, I think let's all work on the PCI things, like with AI clusters, ML clusters. I think the PCI problems are more. I think we should see how many people are staying after 3 o'clock, right? On Friday, right?
I really appreciate that. Thank you. Thanks for good discussion and feedback also. Yeah.
Yeah. I think we should work on the PCI problems. Okay, we want to influence the Linux or like OCP specs. I think maybe think through it. Let's highlight the PCI problems as a next priority for this OCP fault management. Then go to in-band.
Yeah.
So add your pain points to the doc, please.
And the hyperscalers have not been really speaking up about this issue in the past because machines were simple, used for simple applications, stateless kind of application. With these all large cluster applications, AI, these are all now amplifying, right? So this is prime time to discuss and develop solutions.
Yeah, that's right.
I think we have been suffering this pain for a long time. It's just that we've gotten vocal about it recently because we took a step back and said, wait a minute, this isn't right. Life shouldn't be this way.
Yeah.
But Drew, we were able to manage that because software resiliency was there. So we had enough redundancy. Like I like your analogy, right? We had the cattle class fleet. If one machine crashes, who cares? I got 10 more lined up.
Even with that, but Anil, we do some pretty wild things to keep our fleet up. But even with that, PCIe, we do it in spite of PCIe, not because of PCIe. And that's the key is you know, let's all get together and make life better for ourselves, because
Yep.
we're suffering now. We just have been suffering in silence.
Yep,
Yeah,
I
yeah,
know.
yeah. I
Call
think
to
one
action,
thing I want to
consider-
call out is like Meta, especially like they go a little bit deeper and share with industry. I want to call that out. Even like Drew said, right? Like we have this some of the pain points we try to we try to solve like
No,
in
but
different
that's
ways, but
exactly
you guys
the,
share it.
yeah, that's exactly where the OCP becomes very, very relevant, right? Where we can talk about these pain points. If there are common pain points, we should work on a common solution. There's no
Right.
there's no point in solving individually and then
Yeah, yes.
Yeah.
And I think Rama has a good point in priority, right? Let's think about it. PCIe seems like a more urgent and now problem for a lot of
Yeah.
reasons, but let's have a discussion. I think the right call to action, Anil, is to order dinner, but we'll go
Yes.
through this.
Are you buying dinner for us?
It's
I think
5:35.
we all should meet. We all should meet actually, and maybe technical this other than OCP, right? Like maybe we should have like some like
But yes, at OCP, I'm buying everyone first round of drinks. I owe you from last time and also dinner. How about that?
what do you mean first round?
Wow,
What about
nice.
second round?
Second round is on you. Common pain point. a huge failure on my part today. I thought last 15 minutes is 15 minutes, 20 minutes. It's actually 2 hours, 50 minutes. So
Thank you very much for the
This is a
feedback,
great
guys.
topic, though. So thanks, Anil. This is really awesome. I'm excited to dig into this.
yeah. Like that's why I think instead of working on the GPU, we have that PCIe thing. That I wanted to talk these things in that group, but we can use this forum, to get more attention. Yeah.
Sure.
yeah.
Sure.
By the way, I think I sent all of you an invite for Intel reception at OCP. Let me know if you didn't get it, or should be there. Rama, Anil.
Yeah. Thank you. Thank you.
Roy,
everyone.
are you planning to attend, Roy? Are you going to be at OCP, Roy? I don't know if Roy is still listening, but anyway, yeah. So we'll see you all there in a couple of weeks. I'm canceling next 2 weeks. So
Yeah,
All
thank
right.
you, Yogesh. Thank you, Anil. Really
Thank you.
appreciate sharing.
Thank you.
looking forward to seeing you all. Have a good weekend.
Sure.
Thanks,
Thank you,
Anil.
Anil. This is really
Thank
good.
you.
Yeah.
See y'all later.